So we were focusing on MPLS, and in the last class, we saw the importance of VRF and the VPN. I remember I was teaching you about VPN, MPBGP. One of the service that MPBGP provides is a layer 3 VPN service. I was talking about stack of label. I was talking about the service label and the transport label. The service label is the label given over the tunnel for the customer route. Transport label is the one which moves the packet between R3 to R6. Which is the outer layer of MPLS. The outer layer of MPLS will be changing as they go hop by hop, will be swapped with a different label as they go hop by hop. Whereas the inner label, it doesn't change till they go to R6 from R3 or vice versa. And the other part that we just got introduced but not gone deep into it is VRF. We learned like VRF is virtual router. We create virtual routers so that in this topology, the 10 networks which belong to provider will be maintained in a separate routing table. The customer routes 1, 1, 1, 1, 2, 2, 2, 2, 13, 13, 13, 26, 26. All these can be maintained in another routing table separately. So that customer will not get into provider's network, and also provider cannot get into customer's network. Because on R3 there is going to be two separate routing tables. Because they are in two different routing tables, provider can only talk to the customer can only talk to the remote customer. Even though he goes through the provider, he cannot talk to any network inside the provider's network. Even the provider cannot talk to any network in the customer's network. Only router 3 can talk to customer and 6 can talk to customer. 4 and 5 routers cannot talk to customer. Is it good? Of course it is good. Many ways it is good. One, there is no need for customers to talk to the inside network of provider. Likewise, provider also has got nothing to do with customers' network from inside. They don't have any business. So there is a security involved there. For both it is secured. Customer is also happy. Provider is also happy. Another reason, because the customer's networks are not needed for R4 and R5. There is no need to run BGP there. There is no need for BGP at all. So, only the tunnel is going to be between 3 and 6, and only on those routers where the tunnel is, we run BGP. So the tunnel is going to be between these two roads. Yeah. Right. So what we are going to do is we are going to take this tunnel and put it like this. So that traffic will come like this. Even the route updates will come like this, go through the tunnel, go to the remote site. So this guy will know now 1.1.1.1. Likewise, the update of network 2222 will go like this, and now the routing table here will know 2.2.2. So if someone pings 22222 with the source of 11111, see with the source of 11111, why? Only that 11111 is what known to router 2. If router 2 need to respond back, you need to ping from the address which router 2 can respond. Router 2 can respond only to 1111. So source it with 1111. When you ping, traffic goes here, gets the label, gets into the VPN and goes here, and the VPN is removed and now goes to the customer. See, the router 4 and router 5 has got no idea the real source and real destination of the packet. Router 4 and 5 thinks that I'm forwarding a packet coming from router 3 going to router 6. That is what router 4 and 5 thinks. Router 4 and 5 thinks that I'm just giving label for reaching router 6. And when the return traffic comes for router 3. And they process only that label. But only router 3 knows we are actually going to 11111, for which we are going to use label to reach router 6 first and then 11111. Advantage is you no need to run BGP on R4 and R5. So you can simply have one simple router. No need of big processing capabilities. There is no need for big, BGP to run. No need of a big router there. So if you will understand everything that I speak, it will be easy for you to configure layer 3 MPLS VPN. First of all, you bring up this autonomous system. Bring the autonomous system means what? We need to have IBGP between R3 and R6. For that, what is needed? Reachability between R3 and R6. So enable OSPF. enable OSPF, and provide reachability between R3 to R6. After that, bring Bgp VPN, and now the VPN is also ready. What is the next part? Next part is the main part of today's class. On this router B, create a separate routing table using VRF. Call with some name. I'll call 1. Likewise, create another routing table with 2. Simply some name I'm giving, okay, you should by now you should know that VRF name for the same customer can be different. Understand? R1 and R2, they are same customers and they want connectivity. They want VPN. They are same customers in 2 different locations. For the same customer, I can give different name. Name doesn't matter. I want to ask you a question. For the VLANs that we create, does the name matter? Yes or no? No need. The VLAN number only matters, right? That is what I'm going to give now. What is the VRF number? We call it as route distinguisher. This also no need to match. This route distinguisher is also not a VLAN ID. This is also same like a VLAN name. Route distinguisher, I am going to use 11:11. Nothing wrong. I'm very clearly telling you here what all need not to match. Even though this is for same customer 1, router 1 and router 2 or same customers. Even though this is for the same customer, the VRF name and route distinguisher are like a VLAN name only. In VLAN, the name can be different for VLAN 10. You create a VLAN number 10 and you give a name inside name production. On the other switch, you may give name prod. It's okay. So route distinguisher is equal to the name of the VRF. Then why name and then again route distinguisher? That VRF 1 is for you and me to easily handle. VRF 1, the name ONE1. I have given for us to easily call this VRF wherever we want. But as an identifier for the device to use in the algorithm, we need to give the 64-bit value 1:1. 1 is 32-bit colon another 32-bit. So instead of 1, you can also put an IP address colon autonomous system number or autonomous system colon IP address. You need not to holistically follow those things. You can simply put 1:1 also. This is just ID for VRF. What is very important to match is like a VLAN number, we give route target. Route target has got two values, import and export. Import and export are the two things that need to match. These are the two things that should match on the receiving side with the sending side. Only then they can receive. So these are the things that VLANs are made up of. So what I'm going to do, for import, I'm going to give another. Import is also another 64-bit value, like 30 to 30. I'm going to give like 100:100. This is the value I'm using to import. What does that mean? Someone has exported 100:100, which means here I'm going to say 100:100. See, only then whatever this guy exports, this guy can import. I think it should make easy to understand. Whatever the value that you use to export, if someone use it for import, they can receive it. If you use different number, how can you receive it? VLAN number should be same, no? To receive the packet in layer 2 switch, same way. Someone is exporting with the tag value 100:100. If you want to receive it, you should say my import is 100:100. Likewise, if this side, if someone is exporting with 111:111, whoever wants this export, he needs to use the import value 111:111. Correct? Yes. But you know one thing, unless there is a genuine reason, don't do this. Try to keep both import and export same number, 100:100 for both import and export on both sides. That is the best way. For this scenario, what we are seeing now, there is no need for different number for import and export. Keep it simple. Keep 100:100 for both import and export. But if you are using different number, this is how it should be used. My import should be his export, and his export should be my import. Fine. Now VPN is ready with this tag. Now who will carry this tag in the routing protocol? That is what called as Bgp Community Values. Don't think like, oh my god, I did not study community well. Oh Father, what will I do now? How will I understand this? Don't worry. You will understand very well because there is no community need to be configured by you and me. It is automatically enabled and used. You no need to worry about BGP community, but BGP community attribute is what carries these import and export value. That we should know. How this is possible? It is because of tagging. Who is carrying this tag over the tunnel? Now, first of all, what is the tunnel made up of? BGP. So we need to have an attribute of BGP to do this. That is what called as community attribute. That answer you should know. You are not going to enable community. They get enabled dynamically. That how answer, no? That should be known to us. Attribute community is used. That is how it is working. That is the answer for how. Next. So far what we have done is the VPN part is done. Next is we need to run some protocol. Let us keep simple. We'll run BGP here. And we'll call this BGP as 100. This BGP here is 200. And we'll form a simple EBGP. Simple EBGP between R6 and R2, R1 and R3. But remember, R3 interface, that gig Ethernet interface, R3's gig Ethernet interface will be a member of a separate VRF. Like you put no VLAN, you put some interface to VLAN. Now we are going to take this interface G3/0 and put it into VRF called 1. That means we are going to put G3/0 into VRF called 2. So when you are running BGP, you need to run from that VRF, from that routing table, not from the global routing table. We have now two routing tables, right? One for the provider itself, running all the 10.34, 10.45, 10.56, all those 10 networks. Also the loopbacks. Let me have at least one loopback. On R3, I'm going to have 3.3.3.3/32. And on R6, I'm going to have 6.6.6.6. What is this? So we are going to have this loopback. You know why I'm having this loopback in production? We'll use only loopback for this purpose, to form tunnel. Because in production we'll have multiple paths between R3 and R6. So it is always recommended to use loopback interface whenever you form MPLS layer 3 VPN. So the MPLS neighbor is formed with loopback. OSPF will use that loopback as a router ID. MPLS also will use loopback as the router ID. BGP will form VPN using loopback. All are same loopback. So they can easily understand each other and work together. MPLS, BGP, and routing protocol. That's another reason why I should have loopback there. So what we are going to do today is put IP address on every device and keep ready for tomorrow to finish this lab. I do not want even one person to be missing in this class because we got 2 absentees. We will keep it ready for tomorrow. So at least they will see the configuration part. They will not understand after going through today's class, only they will understand tomorrow. But for you, it will be easy for you to understand tomorrow as we do this lab. Now I'm going to just bring those interfaces up, IP address up, and I'm going to run only OSPF on the inside, the provider. What I will not do is, I'll not put any IP address here. I'll not put this. The reason is, tomorrow when we assign that interface to a specific VRF, that address will get removed. So it's a waste of configuration. I'll not put that. And I'll not configure any VPN today. We'll be using these things tomorrow. Today we are not going to do these things. I'm just going to assign IP addresses and I'll make sure 3333 is pinging 6666. And then I'll configure here BGP here and here. That's all. And tomorrow, as soon as everyone comes, we'll start configuring VRF. Assign this interface to the VRF. Put IP address to the interface. And form eBGP using the VRF. As soon as you form VPN and VRF, you will see this 11111 reflecting all the way down here. And you'll be able to ping via VPN. Right, so I have shown you what for today and what not for today. Let's go. This lab is the highlight of this entire CCI program. I tell you, this is the main story of that CCI enterprises. For enterprises, I'm saying. This is the biggest story of CCI enterprises. That's why I do not want anyone to miss. Now let us bring the routers. Let me start from router 1 configuration. Now, before coming to tomorrow's class, if you will do these things, up to the level that I finish, it will be really interesting for you to follow tomorrow. Now, this configuration is for router 1. And now you should be able to understand what I did in R1. I am forming neighbor with R3. R3's address is 13, 13, 13, 3. I'm using physical interface to form physical interface IP address to form neighbor. And I am advertising the network that I have. This goes on router 1. Over. Likewise, router 2. Let's finish router 2. 26, 26, 26, 2. No. Yeah, right. That's right. This is going to be 200. Neighbor is 26, 26, 26, 6. Remote assistant. The network is 2.2.2. That is it. This goes on router 2. Alright. So router 1 and 2, the customer side is ready to provide route. You can see that. Show IP BGP. It will say I'm advertising this. Likewise, router 1 will also say that. Show IP BGP. This is also ready to advertise. But where is the neighbor? Router 3 will complete that neighborship only by tomorrow. So we have kept the customer ready now. Now let us go to router 3. Let me save this one so that we don't need to do this again tomorrow. Understand where we have finished customer. Customer is completely finished. Now let us start from router 3 configuration. Yeah. So this is going to go on router 3. Now router 6 configuration is 56, 6. See, I'm not configuring G3/0. Why I'm not configuring? Because that's going to be a part of VRF, which we are not going to do it today. So this goes on router 6. Done. So router 3 is over, router 6 is over. Just 2 more routers. Now this will be for router 5. Five here. This is on router 5. Next is router 4. I'm sorry, come again. Thank you. Mm, otherwise, it would have taken a lot of time for us to troubleshoot. Excellent, thank you. Copy this and paste it on router 4. Now, what I'm expecting is a reachability between R3 to R6. Let's go to R3 now and check the connectivity. Ping 6.6.6.6 with a source of 1.1.1.1. Sorry, source of 3.3.3.3. Wonderful. So we are not going to do anything more than this. See, we have just enabled OSPF in the core. And we have configured simple BGP on the customer side. This is where we are stopping. So tomorrow is the main story. But we know what is going to be the story. The story will be based on BGP, where we put IBGP. We have not done IBGP. First of all, we will have IBGP. Then we'll have layer 3 VPN, and then we'll connect this VRF routing table to the VPN, so that the VRF will take the route into the VRF routing table from the customer, for which this interface need to be a member of that VRF routing table. So anything comes on this interface will go to the VRF routing table, and it will feed it into the VPN tunnel, and VPN tunnel will take it to the other side, and from there it will go to the final remote site. So the main part is this VPN stuff, which needs two things: MPLS and BGP, which have not even MPLS is not configured yet. Okay, we'll be starting from MPLS. Like today, tomorrow's class will be easy to understand because we break and we do. If you will do up to this level in your home lab and come ready for class. Right, go through this video. If you have any doubts, let me bring it to me. Let me explain you tomorrow. And have a wonderful evening, wonderful day. Take care. Bye-bye. Thanks for joining.